Okay, the second type of reaction is known as fusion reaction. So basically, we sometimes got confused in fission and fusion. So basically, if you want to differentiate between fission and fusion, so by name fusion, so basically the fusion name derived from word fuse, and fuse means to join. So if sometimes you got confused in fission and fusion reaction, so always take the reference from the word fuse. That fuse is fusion is taken from word fuse. So the word fuse means to join. So that will help you to differentiate between the fission reaction and the fusion reaction, because sometimes we know about the reactions, but we got confused that which reaction will combine or which reaction will split. Okay. So in fusion reaction, we can say that a nuclear reaction in which two small nuclei combine to form a large and more stable nucleus. It will also release very large amount of energy. And if we consider the example of the fusion reaction, it occurs at stars, right? And in a star, you can also take the example of the sun. So sun is also the example of fusion reaction. Okay. Because we also consider sun as a star, so basically this fusion reaction also takes place on the sun also, right? Any confusion? And if we consider the equation for fusion reaction, so the equation for fusion reaction is very simple.
Does it occur on any star or just one particular?
It occurs in any type of star. Okay. In space physics, when we start the last section of physics, that is known as the space physics. So in that chapter, we also discussed that how stars use fusion reaction. Okay. So there is a complete topic of star, that how stars will become unstable and what reaction take place. So then this fusion reaction will help you to consider the or to understand the topic of the formation of the stars, right? Okay.
Okay, sorry.
So it will combine and form helium, right? So basically, initially the reaction starts with the help of the hydrogen nucleus, right? And we know that there are multiple isotopes of hydrogen. So two hydrogen isotopes combine, two different nucleus combine, and it will form the helium plus the neutron, right?
Right. Why are isotopes so important though?
Basically, this is the natural process that take place on the surface, right? Okay.
Right.
So basically, we can just derive from the stars because we know that the stars are naturally available there. We are not creating the stars, right? We are not performing the experiment on the stars. So the results we get from the stars, so that shows that there are the isotopes of hydrogen. So those hydrogen combine, right, and form helium atom, okay, and also releases a neutron with very high amount of energy. So this equation is especially for the sun, okay.
Oh, okay. So,
So this equation is for the sun. So we will discuss the same process in the space physics also, that how hydrogen helps to form the helium nucleus, because you know helium is heavier as compared to the hydrogen. So we combine two smaller nuclei of hydrogen and make a heavy nucleus of helium. Okay, so this is the reaction of fusion reaction. Any confusion? And if you consider the chain reaction for fission and fusion, fission and fusion. So the chain reaction for the fission will look like this. Let's suppose if we consider for the fission, we just strike one neutron on a heavy nucleus of uranium, right? So this neutron strikes the heavy nucleus of uranium and it will splits into, so it splits like this. One neutron, those two elements, right, that we note down in the equation, and then again in neutron, right? And then this neutron
right.
further strikes, yes, it further strikes the nucleus of the other element also, and it splits into further more elements. So this is neutron. This is any element. I am writing just X and Y to show the unknown elements. And further it strikes the remaining nucleus of uranium, and further it splits into neutrons, and again some elements, and into further neutron. And now you can see at the same time there are two reactions taking place in the nuclear fission, and it will continue so on. So you can see it will work like a chain reaction. Okay,
Okay,
we
sir.
are getting neutron, element, element, neutron, again neutron, one element, second element, and neutron. So this is the chain reaction for the nuclear fission reaction. This is neutron, this is neutron, Okay.
Yes, sir. What about for fusion?
Yes, for fusion, we can write the equation, draw the diagram like this. So for fusion, we just take the example of two elements that are the isotopes of the hydrogen. So let's suppose this is the first isotope and this is the second isotope. This is the positive one and this is also the positives, right? So you can see two deuterium 2 and deuterium 3, sorry, tritium. These are the isotopes of the hydrogen. So this is deuterium. So when we
Sir, I
come,
have a question.
yes,
For the fission part, when one uranium, for example, turns into another element, what happens to the electrons? I don't understand that part.
basically electrons are still there with the nucleus because we know that electrons are always revolving around the nucleus, right? So when it splits into different particles, so electrons are still there, right? All elements are there, so electrons are still revolving around the nucleus. Okay, because we have still nucleus. Nucleus will not die completely after the reaction. Okay, because it will take many
Okay.
years, like hundred and thousand of years to decay a single atom, right? Because if the element decay very quickly, so the molecules present in the airs will also die very quickly, right? And there will be less oxygen in the atmosphere. Okay, so it will not happen very quickly, right? For the example, for the question, we take very small time period, right? But that will not decay very quickly. They don't have very short half life. They have short half life, but not very short, like for few minutes or few seconds.
Okay.
So in fusion reaction, they will combine. This will be the positive, this will be the positive also, and then it forms a helium and the energy releasing from the reaction. And you also observe that very high amount of energy is releasing from the sun. So you just observe practically that how much heat you are getting from the sun. Okay, so it just makes and combines over here. Positive, positive, and one neutron, plus we are also getting very high amount of energy.
I have a question.
Yes.
In hydrogen bombs, both nuclear fission and fusion happens. How does that coincide with each other?
Basically, that is a complete different process. We will discuss surely in the next class also, right? Because there are still some concept left in this chapter, right? So we will also discuss that, right? Don't worry about that. Okay?
Okay, thank you.
Because next time we have to discuss also the nuclear reactor. Okay, so in nuclear reactors, and then we are starting the concept of the theories of the star formation. So in that we also discuss, right? That why we are using hydrogen in the formation of the stars, and why, what is the difference between the hydrogen bomb and the nuclear bomb. Okay, so don't worry about it. Just
Okay.
like the last time you asked me what are the elements, so today we discuss about those elements, right?
Yeah.
So one by one, we will discuss each and every concept, right? Actually, I divide like this that in single class, we discuss about only one concept, so you just focus on it, right? So today we discuss about the equations and the type of nuclear reaction. So in next class, we start with some questions of these reactions, right? And then we will discuss the nuclear reactor. Because if you got the clear concept of fission and fusion, so nuclear reactor is just an application, right? You just need to know, yes, that these things will work like this. And there are many documentaries available. I will also share the link. So if you want to check out that how nuclear reactors practically work, right? So you may check those documentaries that will help more to understand the topic, because in video you will get the concept like a story, right? And that will be remain in your mind, yes, that this will happen in that reaction. Okay. And there are two also movies that is currently going on. Like one is the Oppenheimer, and second one is the old one, Chernobyl. The name of the movie is the Chernobyl. Chernobyl is basically a name of the place where the nuclear plant is set up in 1950s, I think. So they are testing the nuclear power plant, and they want to
Oh
just
yes, done.
complete that process very quickly. So for that, they just boost the process of the nuclear reaction, and in that result, it explodes whole nuclear reactor, right? So these are real incidents. So I will also share the link. So before next class, you may check those links. So that will automatically give you the idea that what are the elements and what are the components we are using in the nuclear reactions. Okay.
Understood, sir.